Crash Course on Astronomy. Observational Astronomy. Learn about different observational techniques and how astronomers study the universe. Astronomy is the study of the universe, including celestial objects such as stars, planets, galaxies, and other forms of matter and energy. It is a fascinating field that has been studied for thousands of years, dating back to ancient civilizations. One of the key aspects of astronomy is observational astronomy, which involves the study of celestial objects through direct observation using a variety of techniques. Observational astronomy is essential in helping us understand the universe and its evolution. Astronomers use different techniques to observe and study the universe. Some of the techniques include observing electromagnetic radiation, studying cosmic rays, and detecting gravitational waves. One of the most common techniques used in observational astronomy is optical astronomy. Optical astronomy involves using telescopes to observe visible light from celestial objects. Astronomers use this technique to study the properties of stars, planets, and galaxies. They can also use it to determine the distance between celestial objects, as well as their size and composition. Radio astronomy is another technique used in observational astronomy. This technique involves using radio waves to observe celestial objects. Radio waves have longer wavelengths than visible light, which allows astronomers to observe objects that are otherwise invisible in the visible spectrum. They can use this technique to study pulsars, quasars, and other objects that emit radio waves. Infrared astronomy is another technique used by astronomers to study the universe. Infrared radiation has longer wavelengths than visible light, allowing astronomers to observe objects that are too cold to emit visible light. They can use this technique to study star formation, the structure of galaxies, and the composition of planets. Ultraviolet astronomy is another technique used by astronomers to study the universe. Ultraviolet radiation has shorter wavelengths than visible light, allowing astronomers to observe objects that emit ultraviolet light. They can use this technique to study the structure and evolution of stars, as well as the interstellar medium. X-ray astronomy is another technique used by astronomers to study the universe. X-rays have shorter wavelengths than visible light, allowing astronomers to observe objects that emit X-rays. They can use this technique to study the structure and evolution of galaxies, as well as the behavior of matter in extreme environments. Gamma-ray astronomy is another technique used by astronomers to study the universe. Gamma rays have even shorter wavelengths than X-rays, making them useful for studying high-energy events such as supernovae and black holes. Neutrino astronomy is a newer technique used in observational astronomy. Neutrinos are subatomic particles that are produced in the Sun and other celestial objects. Astronomers can use detectors to study the neutrinos that are emitted from these objects, which can provide information about their structure and behavior. Cosmic ray astronomy is another technique used in observational astronomy. Cosmic rays are high-energy particles that originate outside the solar system. Astronomers can use detectors to study these particles, which can provide information about the structure and behavior of the universe. Gravitational wave astronomy is a relatively new technique used in observational astronomy. Gravitational waves are ripples in spacetime that are produced by high-energy events such as the collision of black holes. Astronomers can use detectors to study these waves, which can provide information about the structure and behavior of the universe. Top 12 different observational techniques and how astronomers study the universe. 1. Optical astronomy, observing visible light from celestial objects to determine their properties, size, and composition. 2. Radio astronomy, observing radio waves from celestial objects to study pulsars, quasars, and other objects that emit radio waves. 3. Infrared astronomy, observing infrared radiation to study star formation, the structure of galaxies, and the composition of planets. 4. Ultraviolet astronomy, observing ultraviolet radiation to study the structure and evolution of stars and the interstellar medium. 5. X-ray astronomy, observing X-rays emitted by celestial objects to study the structure and evolution of galaxies and the behavior of matter in extreme environments. 6. Gamma-ray astronomy, observing gamma rays emitted by celestial objects to study high-energy events such as supernovae and black holes. 7. Neutrino astronomy, studying neutrinos emitted by the Sun and other celestial objects to provide information about their structure and behavior. 8. Cosmic ray astronomy, studying high-energy particles originating from outside the solar system to provide information about the structure and behavior of the universe. 9. Gravitational wave astronomy, studying the ripples in spacetime produced by high-energy events such as the collision of black holes to provide information about the structure and behavior of the universe. 10. Polarimetry, observing polarized light from celestial objects to determine the magnetic field strength, orientation, and other physical properties of celestial objects. 11. Astrometry, measuring the positions, distances, and motions of celestial objects to determine their physical properties, such as mass and luminosity. 12. Spectroscopy, studying the spectrum of light emitted by celestial objects to determine their chemical composition, temperature, and other physical properties. These observational techniques have led to many fascinating discoveries and advancements in the field of astronomy. For example, the discovery of the cosmic microwave background radiation using radio astronomy helped to confirm the Big Bang theory. The use of X-ray and gamma-ray astronomy has helped to identify black holes and study their behavior, while the detection of gravitational waves has provided insights into the structure and evolution of the universe. In conclusion, observational astronomy is an essential aspect of studying the universe. Astronomers use a variety of techniques, including optical, radio, infrared, ultraviolet, X-ray, gamma-ray, neutrino, cosmic ray, and gravitational wave astronomy, as well as polarimetry, astrometry, and spectroscopy. These techniques have led to many fascinating discoveries and advancements in our understanding of the universe and its evolution. As I look up at the starry night, my heart fills with wonder and delight. The beauty of the universe on display. Observational astronomy shows us the way. From visible light to gamma rays. Astronomers study the universe in countless ways. Through telescopes and detectors they observe, revealing the secrets that celestial objects preserve. Radio waves from pulsars and quasars. Infrared radiation from star-forming nebulae, no bars. Ultraviolet light revealing the structure of stars. X-rays exposing the behavior of matter in extreme environments, no jars. Gamma rays uncovering high-energy events. Neutrinos revealing celestial objects' structure and contents. Cosmic rays originating from outside the solar system. Gravitational waves revealing the universe's rhythm. Polarimetry measuring magnetic field strength and orientation. Astrometry determining celestial objects' position and motion. Spectroscopy analyzing the chemical composition and temperature. Observational astronomy uncovers the universe's structure and nature. As I gaze at the stars above, I'm reminded of the beauty and love that exists in the universe we call home. Observational astronomy reveals how it has grown. *****. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html $aid equals 7989335 as a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our AnHub Metaverse channel, and please watch more interesting videos here.